The first in our summer series, Building Better Stream Monitoring Programs, Strategies, Innovations, and Success Stories from Local Governments. So lots of great things, great reasons to join the network. Like I said, it's free. You can scan that QR code at the bottom of the screen, or you can go to our website, which is chesapeakestormwater.org, and you can sign up there. You also get our wonderful monthly newsletter, the Stormwater Scoop, that Michelle puts out. It's got lots of really great information. And then we have 2 more upcoming webinars this summer. So on September 8th, we'll be speaking with the developers of a new white paper that was recently released about GSI maintenance gaps and learn about some of their findings and recommendations. And then on September 10th, we'll be discussing new tools and guidance for how to apply climate-informed precipitation projections to resilient stormwater design decisions. If you'd like more information about how to register for those webinars, we'll pop the links to those in the chat as well. All the information can be found on our website, also under the webinars tab. All right, so finally, I'm going to start opening our webinar today. So again, Building Better Stream Monitoring Program Strategies, Innovations, and Stormwater Stories for Local Government. Our speakers today are Matt Gallagher, Eric Naibert, and Chris Ruck. So I'm going to start with Matt. Matt Gallagher is the Planning Administrator for Arundel County's Bureau of Watershed Protection and Restoration, where he administers the county's TMDL implementation of the MS4 permit and ecological monitoring programs. Prior to joining the county, Matt oversaw the District of Columbia's MS4 permit and state revolving fund programs. He holds a Bachelor's of Science in Biology from Dickinson College and a Master's of Science in Biology from Towson University with a focus on watershed ecology. And then Eric has over 23 years of experience in stream health assessment, 20 of those being with Montgomery County as a water quality specialist. He's currently a water quality specialist 3 and manages the county's special protection area monitoring program for DEP, and he participates in the various biological monitoring tasks done under their MS4 permit. Eric holds a Bachelor's of Science in Geography and Environmental Systems from UMBC. And we also have Chris Ruck joining us today. Chris is an aquatic ecologist at Fairfax County, leading a team conducting water quality monitoring and analyses. With over 20 years of experience in physical, chemical, and biological assessment, Chris strives to communicate science-based information to the public while maintaining experimental rigor. So I just want to say thank you guys for joining us today. I will stop sharing my screen and I'll be turning it over to Eric to begin.
Okay. Good morning, everybody. Can you see my screen okay?
Looks great.
All right. Very good. So today, my name is Eric Naibert. I'm from Montgomery County, Maryland. As she mentioned, I'm one of the water quality specialists here. And today I'm just going to be telling you a little bit about our monitoring program, its evolution, and a couple of sister programs that we do besides the biological monitoring, most of which revolve around some sort of law changes or policy changes, either at the local or state level. There we go. All right, this is me. I'm in a stream. It's what I do most of my summer, most of my spring, quite a bit of my winter. The rest of the time is here doing these administrative tasks. So the county's programs were started in around 1994. There was quite a bit of a break from the previous water quality programs that were done by the county. The current program was in response to rapid population growth in the county. The county executive wanted a new tool to serve as a report card for the impacts from this massive amount of development in the county as it went from a rural and forested watershed dominated county over to one with lots of thriving populations. I think the county population, I don't know what the current is, but it is rapidly increasing still. So we came up with a program idea for biological monitoring, kind of as a surrogate to the traditional chemical and physical chemistry monitoring that really didn't give a broad picture. It only targeted specific chemicals. So the assumption is that the living things are going to integrate and reflect the effects of their surroundings. So whether it's changes in the physical habitat or the chemical contributing stressors. We formed a work group working with EPA's rapid assessment protocols, and then we developed reference conditions. At the same time, we did some baseline conditions. Our reference conditions established our excellent and our good criteria. 10% of the reference stations were what created our excellent category, and the good makes up the rest of our reference sites. And then fair and poor kind of shook out with some of the statistical models that were used. We created an index of biological integrity. Again, with some guidance from EPA's biological criteria team. We worked with Maryland Biological Stream Survey also to set up and use some of their Sentinel sites for creating this IBI. We did the IBI based on ecoregions and also stream order. The indices that we came up with that will describe the stream health, they vary between the macroinvertebrates on the left of the screen and the fish on the right. And these indices have different breakpoints based on stream order and ecological region. So a first order stream in the western part of the county is not going to have the breakpoints that you will find in a fourth order stream on the eastern part of the county. And this is true for both of our sets of metrics. So both of our programs have changed a little bit over the course of time with the biological monitoring, more so with the approaches to monitoring stormwater management technology. I think there's been more evolution in the stormwater management techniques over time. We've been pretty static in our baseline program since 2021. The 2011 mark is significant because we had a huge reduction in the number of sites just due to economic downturn. 2021, the program was revamped for the NPDES permit, which has become a driving factor of our program. We used to select all of our sites and do a 5-year cycle, come back to the same sites. And one of the things that we learned around 2018 was actually a result of a pretty unusual weather pattern, very rainy season. We realized that if we continued to just do a watershed a year, it would give us some really abstract results when we looked at the next cycle that wasn't monitored. So we shifted away from that 8-digit watershed scale to a 12-digit random stratified approach. And again, that's one of the drivers is our NPDES permit. That permit's also asked us to start looking at TMDLs, bacteria, chloride, PCBs, and trash are just a few of the things that we look at. There's PCB source track downs. We're looking at sources of chloride, bacteria. SPA monitoring program also was started in 1994. We utilize a lot of the same biological data that is collected under our baseline program that we use for this SPA program. In 2010, with the advent of the environmental site design, it changed a lot of how we monitored all of that stormwater technology. And then in 2013, we actually had some changes in SPA law, which transferred the monitoring responsibility from the development community over to the county. So we also had to really ramp up how we looked at these sites. This is an example of how we used to collect our data. All the green triangles represented the sites that would have been monitored in a given year, with the exceptions of the ones in those red polygons. Those are our special protection areas for the county. They were set up with the intent that we would have more stringent stormwater management measures for those ecologically sensitive areas, and those were protected by SPA law. There's also purple dots down in the middle is one of our special projects. You'll see that's also clustered. This is how we currently monitor these yellow stars as a 2026 iteration using that random stratified approach. So we collect data all across the county in a single year now, as opposed to coming and only visiting a certain watershed once every 5 years. This next slide is pretty much every place we've sampled in Montgomery County and reported on it through one of our either our SPA monitoring or our CSPS program, which was one of the beginning programs that has kind of shifted away, but we might bring that back. These different sample locations have allowed us to generate a overall report card, as I mentioned before, about the stream health. And so this is an example of how the report card was in 2012, showing those categories. Currently, the map looks substantially different, in part because we've been asked to begin thinking about things like ADA, American Disability Act, and apparently this color palette is more readily visible to people who are red-green disadvantaged. So this slide is just showing several stations in the Clarksburg Special Protection Area. The top graph is our control site. It's in a forested parkland setting, and we have data back to 1994 on that through 2026. The second graph down shows the urban control. That was our 2007 stormwater management technologies that were in place. Most of that watershed was protected with wet ponds at that time. And then the next two graphs down are showing the next iteration of stormwater management protection. Basically, that would be single cell, double cell, stormwater ponds, sand filters, redundant treatment. And then the last two are showing the advent of the ESD practices that are beginning to take over in our county in force. They're much smaller microbiofilters that treat up to 20,000 square foot as opposed to several acres. If I've got a little extra time here, I can do a quick case study in the environmental site design. The first study that the county did all on its own was Clarksburg Premium Outlets. It continues from the rest of our information that we collected at other sites in previous years. The main components of this were surface water quality, like physical chemistry. We did that also at the outlets of several of the bioretention facilities that are on this project. Had groundwater wells. We had looked at flows and rainfall. Quite a bit of time and effort and money was put into this project. So this was our study site. This was our control site across 270. This was traditional stormwater management. So we looked at a lot of the same parameters for this as our control. And the reason we were looking at this particular spot is because we do have about 20 years of biological data downstream. We watched this go from a cornfield agriculture setting to this mass grading, and the amount of biofiltration on this is sort of staggering. There's on a 100-acre site, we've got almost 150 structures. On this left side, we have about 80 different structures in that little circle. And on the right side over here, we got about 60. They're those very high impervious areas. The results, I'll breeze through those real quick. We looked at the surface water chemistry. We looked at various constituents of concern. I won't get into all the data. I don't have time today, but I'm certainly happy to share this with you and let you look through it. We looked at pre and post conversion at the BMPs to look at whether things that were soluble or attached to sediment had better or worse efficiencies. Groundwater chemistry showed some differences that were fairly obvious to us when we looked at the chloride. Pre and post construction, there was a fairly intense increase at some of the sites and not others. You can go through this data if you're interested. Again, we looked at groundwater chemistry at one of the BMPs. We saw increases in nitrogen, nitrate after the conversion. Same thing with phosphorus. Responses to groundwater were also apparent. Post-conversion, we saw an increase in the groundwater elevation changes after that conversion. This is an example of how one of the biofilters is constructed. It's all drains to a concrete vault that's got a liner at the bottom of it. They do it that way to protect the infrastructure. So what you see here is going to be different than something in a residential neighborhood where they have area where they're really focusing on infiltration. This does not focus on infiltration. It focuses on the biofiltration and safe conveyance offsite. Some more graphs about the upstream downstream during storms. And I'm stealing some of these slides from a colleague at Versar who helped me with a presentation a couple of years ago. So that's kind of why I'm breezing through these really quick. He knows more about those. This actually was what we wanted to show. It was really peaked us. All these purple spikes are the responses to their watering events overnight. So we could see even them watering the biofilters for the plants that they had in it. And then the green would be our rainfall events. So we really were able to see exactly how quickly these biofilters process the rainfall, or in this case, what's coming off of the sprinkler systems. We did geomorphology there too. The graph on the left shows the fill that was experienced during the course of the study at the test site, and our control cross section on the right stayed very stable during that same time period. We did longitudinal profiles too that shows the fill, and there's actually a head cut that was moving upstream at our test site, and that shows up in the profile on the left, and it continues to move upstream. One of the takeaways was that all these protections we're putting were still not enough to prevent this kind of head cut migration.
Eric, I hate to kind of push you along. Let's go for about one more minute and then we'll switch to Matt. Does that sound okay?
That's perfect. So here's just a slide on the overall stormwater effectiveness. I know I was running tight. Sorry about that. So we were able to maintain groundwater levels. We did find that the non-ESD practices that they had to use to stabilize the infrastructure kind of confounded our thought process on ESDs. So our next project is in 10 Mile Creek, across the street there in the other SPA. We have some really good ideas for residential ESD to monitor, and we'll be able to provide some graphs for you guys, hopefully in our next presentation. Thank you guys for having me.
Thank you, Eric. And everybody, if you do have questions, we are going to, we save time at the end to be able to do questions. So please pop them in the Q&A as Matt is getting ready to go ahead and share his presentation.
Okay. Hi, everyone. My name is Matt Gallagher. I'm the planning administrator in the Arundel County's Department of Public Works, Bureau of Watershed Protection Restoration. I've been here about a year and a half. If you're interested, the QR code on the left-hand side here takes you to our Ecological Assessment and Evaluation Unit's website. Due to time, I'm going to be pretty high level about the projects that I'm going to talk to you about. So for the purposes of this presentation, I broke our ecological monitoring programs into two main buckets, MS4 permit required monitoring, which at the county includes participating in the pooled monitoring program, our countywide biological stream survey, and PCB source tracking efforts. And then I'll also talk about two of our non-permit driven applied monitoring programs, including a stormwater pond study and some of our innovative eDNA work. And these are just fun pictures. I'll probably breeze through this. MDE allows the county to pay into the pooled monitoring program, which is managed by the Chesapeake Bay Trust. In lieu of conducting some of the specific monitoring that the permit requires. We fully pay into the program for the BMP effectiveness track, and we partially pay into the watershed assessment track. And I'll get into a little bit next. This is just a picture from this year's pooled monitoring forum. There's a link there if folks are interested in that program. The part of the watershed assessment track that we do not pay into is the biological monitoring and habitat assessment monitoring at randomly selected locations throughout the county. We call this our countywide biological stream survey, and we do conduct that in-house. The permit requires us to conduct a minimum of 25 sites each year, and we do 40. At those sites, we collect benthic macroinvertebrates, fish, habitat, and water chemistry. The map on the right shows our current schedule for this permit term so that every one of these areas is sampled during the permit term. Note, it's sort of in the middle if you can see Severn Run, which is kind of pinkish. That is one of this year's primary sampling areas for monitoring. I'm going to come back to that later for the eDNA work. The third MS4 permit required monitoring is PCB source tracking, which we've done a lot of work in. The county has two PCB TMDLs, one in Baltimore Harbor and Curtis Creek, and the other in the Patuxent watershed. We've been working with researchers at the University of Maryland, Baltimore County to conduct some multi-phase source identification of PCBs using their patented passive sampler technique. You can see the pictures there. The goal is ultimately to identify and reduce PCBs in those TMDL watersheds below the water quality endpoint of 0.27 nanograms per liter. We decided to focus again I wasn't here at the time, but the county decided to focus on the Baltimore Harbor area first. We conducted a desktop exercise using a variety of resources to identify potential PCB source sites, and that led to us focusing on Sawmill Creek in the Baltimore Harbor. In 2020, we initiated phase one, where we deployed these passive samplers in 15 locations. And the results were that we had significantly elevated PCBs, so well above that TMDL endpoint in Ferndale Branch and North Glen Branch. On the map here on the left, those are sort of the yellow and purple circle-ish shapes that I drew in there. After that, we did phase two in 2022, and then we targeted deployment of 11 samplers in those two areas, Ferndale Branch and North Glen Branch, and we saw decreased PCBs in both watersheds from phase one, still elevated over the endpoint, but decreased. Then in 2024, we initiated phase three, which is basically sort of recreating phase two to verify those results. And we saw a continued decrease of PCBs there, ultimately with a overall PCB contribution in Sawmill Creek below that TMDL endpoint of 0.27 nanograms per liter, which is great. Some of the potential reasons there might be, there was a stream restoration in Ferndale Branch and a stormwater retrofit at a PCB era building in North Glen. Those could be why we saw pretty significant lower PCB contributions. And now we're expanding that process to other catchments within our TMDL watersheds. So we have a lot of work to do, but this is, sort of the process that we're going to follow. Moving on to our applied monitoring projects. Hopefully everyone here is familiar with stormwater ponds. Broadly speaking, they're designed to allow for settling of sediment, remove nutrients, sometimes reduce flooding. They're also typically vegetated with turf grass, which needs regular mowing, and mowing costs money. Arundel County manages hundreds of these ponds, so our team asked the question, can a transition zone of native grasses and wildflowers improve pollutant reductions while also reducing maintenance costs of these ponds? We designed a study using 14 ponds, 7 of which were chosen for a vegetated buffer. You can see the picture on the right-hand side is like right after the seeding of the buffer of one of those ponds. And then 7 ponds as a control. We did 2 years of pre-buffer monitoring from 2024 to 2026 for water quality sampling. The buffers were installed this past May. They'll sit for a year to establish, and then we'll do 2 more years of post-buffer monitoring of water quality. So look for those results in a couple of years. And this is a picture of some of the signage that we've put up at those ponds for education purposes. Moving on to eDNA. For those that aren't aware, eDNA is a method where you collect genetic material directly from the stream, send those samples to a lab, and then compare those results against a list of species that are likely to be in that area. At the moment, you can really only use this for species presence, not abundance. Our team developed a pilot project in 2024 with 3 main goals. One was to explore 2 sampling methods, so these 2 the disc filter and then the large composite filter. Second, to compare the taxa list from eDNA versus the MBSS, macroinvertebrate, and fish methods at 11 sites, and then to assess 4 primers, 3 of which were for vertebrates and 1 for invertebrates. So results for the 2 filter methods, the disc filters outperformed large composite filters, so we are using those disc filters now. Unfortunately, eDNA was not successful at identifying macroinvertebrates when compared to traditional MBSS jab sampling method, but eDNA was quite successful at identifying fish species when compared to the MBSS method, with no significant difference between the 2. For those interested, the Me Fish U primer was great for fish, and the Vert S12 general vertebrate primer was great for identifying amphibians. And then just separately, having adequate flow was really important. The method did not work well in low or no flow pools or wetlands, so that will come into the next section. So with that pilot project completed, we had to figure out what to do next. If you recall earlier, I said that the Severn Run watershed was one of this year's primary sampling units for the permit required monitoring. It also was selected as designation in the Whole Watershed Act. And we wanted to do a watershed scale eDNA project in Severn Run. This project, the 8 randomly selected sites within Severn Run covered less than 1% of the stream network. And it doesn't allow for looking at the ranges of different species and likely misses some taxa, and it's expensive. So we are doing extensive eDNA sampling at up to 150 sites this summer. if we do all of those, it would cover over 80% of the stream network, allow for a more comprehensive distribution of species across watershed, um, hopefully detect some less common and sort of rare, threatened, or endangered species that might otherwise be missed. And we also invested in an equipment upgrade with a backpack sampler. This is the map of Severn Run watershed. The little blue sort of circles that I hand drew are the 8 electrofishing sites. All of the other dots are our eDNA sites. So far, we've gone to 78 of those sites and collected 66 samples, some of which we couldn't, some of those 78 sites we couldn't do due to low or no flow, or they were just straight up dry. Okay, here's the test. Will this video work if I press it? Is he shaking her head yes, which is good. It's short. This is just showing how the new backpack sampler works. Yes, it is heavy, but it does make sampling a lot more efficient than our prior setup. Sort of closing out, here's our anticipated schedule for this project. Long story short, we should have results to share next fall because we have to send them off to the lab and then do the analysis. So expect maybe next fall we can have things to share. And then I'm done. And if you're interested, my email is down at the bottom, and feel free to share Public Works or BWPR on social media.
Hi, everybody. I'm Chris Ruck. Can you see my screen?
Yep, looks perfect.
Perfect. Okay. All right. Let's see if I can advance. There we go. Okay. I'm from Fairfax County in Virginia. One of the things that I wanted to echo that some of my colleagues have talked about already is that we started a long time ago with great support from the elected officials and management that wanted to find out what was the condition of our streams. And we've had continual support throughout that, and that allows us to kind of see how are we doing with our policies and implementation and the different best management practices so that we can try and adapt either new technologies for monitoring or or seeing that new technologies are working. From a regulatory standpoint, we have 5 areas that my team deals with related to the MS4 permit. You can read them here, but I'm going to go into each one of them very briefly. First, we have our wet weather screening that's looking at storm event sampling, and we're targeting areas of high industry or high likelihood for pollution. We use auto samplers. We are now switching that over instead of 2 times per year with auto samplers to 8 grab samples per year, trying to track these down a little bit more efficiently. We use dry weather screening at stormwater outlets, and this is a screening program to see if we have illicit connections. This is really good at trying to track down those connections because things are not supposed to be flowing in dry weather. So again, we do this in the fall most years, and we do over 100 sites per our permit. We have something called in-stream monitoring. It has a suite of analytes that we have to do, and we do this coincident with 5 of our USGS gauging stations 6 times per year, so every other month throughout the year, and we take these to a lab and analyze it. We also do physical habitat assessments, and these are essentially the EPA's RBP, slightly modified, but again, most people on this call should be familiar with this type of thing. And then the last one is biological monitoring. We use a 100-meter multi-habitat bioassessment deep frame, 500 micron deep frame net, looking at 20 half-meter habitat patches. And, everybody's locality may be slightly different, but again, it's getting at that same thing. And then we have both the state's family level index, and we have our own multi-metric, locally calibrated genus level index. And then when we initially started that program, we started a comprehensive biological monitoring program, and this is similar to kind of the direction that Eric said that they took in Montgomery County. Is we started with a probabilistic program where we have a stratified random design. We've since refined it. It used to be order and 2 physiographic provinces. We've now gone to stream catchment area and 3 physiographic provinces in terms of how we're sampling in our stratification, because we've learned a little bit that there are really fine scale differences in terms of the water chemistry and the biology within small watersheds, even in something as small as Fairfax County's 400 square miles. These are the things that we were taking a look at, and oh boy, there we go. Okay, these are the things we take a look at, and then we have a bunch of other special projects and programming and all sorts of programmatic monitoring that we do. I'm going to talk about our seasonal effects monitoring and our stream physical assessment monitoring. These two won Chesapeake Stormwater Network BUBBA awards about a year ago. So I just wanted to give you that background. So the seasonal effects study started with our requirement by the state for us to monitor both in the fall and the spring. We subsequently, prior to that, we had only monitored in the spring. And what happened was, after 3 years in our a new permit cycle, we were seeing a significant difference of almost 20 points on a 100-point scale between the fall and spring benthic samples. So we're like, this is pretty interesting. So I went to my supervisor and said, can we start a study? And just this is where our pass-fail is for the state on the state index. And I said, can we take a look at this? And we said, yeah, we need to look at both urban sites and we need to look at our reference sites. And these are just icons to kind of track that for you. So, median urban site is about 24% impervious, and a median reference site is 1% impervious. So I'm just going to jump into the results. And what we saw that in both the urban and suburban sites, we saw an increase in the quality in the fall and a decrease in quality in, in the spring. So, and yes, so I'm sorry, a decrease at urban sites, we had an increase in quality in the fall, and in the reference sites, we had a decrease in quality in the fall or an increase in the spring. So these were going in opposite directions. So it really matters which time of the year you're monitoring, because the reference sites and urban sites will look very similar, or can look very similar in the fall, where they can look even more different in the spring. So anyway, this was a very interesting piece for us to look at. We did a bunch of other analysis, and the big thing I wanted to do was take a look at an NMDS. Each one of these dots represents a point in time, a particular year at a particular site. And what this shows you is that there's a very big difference between our fall and springs at both the urban sites and the reference sites. And when I draw these lines, just to kind of visually separate that for you, and then I put a new way of looking at those data on here, in the urban and suburban sites, you can see from down here, you have low impervious areas to high impervious areas. So on each side, you're seeing this kind of gradient up here. And at our reference sites, it's not, it's on the size of the drainage bin. So the larger the site, the larger sites are pretty similar, and you have a gradient in both directions. So there's a difference in fall and spring, and there's a gradient along the size of the drainage area. So the takeaways from this was really that we see seasonal variability at both reference and urban and suburban areas, that you have this watershed impervious surface effects, and that habitat metrics, again, we also did this for all of our habitat, and we did this for water chemistry, and it also has this stuff where it varies by physiographic province as well. So again, we're seeing this in a bunch of different ways. The other program I wanted to quickly talk about is called our Stream Physical Assessment Program, which we initiated in 2018-2019. This is to look at targeted stream corridors, looking for those areas that need some improvement. We were trying to supplement some of our watershed management plans where we were running out of good quality stream restoration projects. So how do we decide how to do this? We looked at we have 30 major watersheds in Fairfax County that were subdivided into watershed management areas, and then subdivided again into sub-watersheds. And we looked at those drainage networks, and we said, let's try and assess that entire drainage network. And we came up with 3 assessment methodologies. One is called a full assessment, which we look at 20 metrics that includes both RBP metrics and some other stability metrics that are then captured in another one. We're looking at larger streams, and you have to walk the entire stream length, usually twice, at least once, usually twice. And then we have a rapid assessment that includes 9 of the same metrics that were assessed in the other area, but this is for stability only and is really good for both intermittent and ephemeral streams as well. And this one takes about 3 to 5 minutes. It's a very short way to assess the stream. And these both sync up with our current evaluation in terms of how we scope streams and prioritize streams for stream restoration projects. We also have something that's called no assessment needed, and this is pretty self-explanatory when there's really not a stream there, but you see a drainage on a map, so you have to go out and check it and take a look. And these are the types of things that we would kick out immediately. We use mobile collection technology. We were the first ones in the county to start using mobile collection technology for this. And so what you can see is once you conduct the field work, you can see there are these green dots and the purple dots, and the green dots are ones that had an inspection, and the ones that had no inspection needed are the purple dots. And again, this is very helpful for field staff to move along quickly. And then once we get back and we process the data and we QC the data, we get a map of all of those sub-watersheds and what their overall ranking is. And this is a length-weighted approach, and it gives us an idea of where we might want to target some of our projects or potentially target areas for protections. So, and when you zoom in on this, you can start to see the sub-watershed codes pop up. And if you zoom in even further, you can start to see the actual stream segments and how they scored, which again is really helpful. So for instance, this red one right in the middle is a very poor reach. So if I was to click on it, you would get a little more information on what we actually saw there. There's a whole host of other pieces of information that we collect with this stream physical assessment program, but again, I wanted to quickly just briefly go through these 2 things and a little bit about how those are things that we do go above and beyond. We couldn't do it without this great staff that we have. We can't do it without support from our management and from the Board of Supervisors, who continually ask us to do more and more monitoring. So they do a great job of funding us, and if you have more questions, feel free to use this to contact me. Thank you.
Awesome. Thank you so much. And that was an amazing whirlwind, like really, really quick presentation. We appreciate it. That was fantastic, Chris. Thank you so much. Right now, so we're going to kind of transition into questions to begin with. We had a couple come in from the start for Eric. So Eric, one person asked, how does the county hope to include new monitoring of plastics, trash, PFASs in future projects? Are there any resources to implementing these in volunteer programs?
I do not know the answer to that. I haven't had a lot of exposure to that. I certainly will. I'd be happy to forward that over if you send me an email, spark that memory, and I will take care of that for you.
Awesome. And then the other one, Eric, that came in for you, could you share a little bit more about what you hope or expect to see from the results from the watershed with ESD only practices, particularly compared to your results for the confounding non-ESD practices?
Yeah, I guess we were expecting some of the results that we got to be different than our traditional stormwater management. Maybe not to this extent, because the immediate response to rainfall and the fact that the way these things are designed really, I mean, it goes against what we've been taught about ESD doing infiltration. And, we did see impacts to local groundwater, but it's different than what we expected to see. And hopefully when we get some practices that are not designed with that infrastructure protection from our next round of monitoring, we want to be able to see whether we're going to see those kinds of effects in the groundwater. I mean, part of the chlorides question with this wasn't answered because we realized, just based on some of the modeling that was done, that we were probably getting a lot of offsite kind of cross-contamination from some of the development surrounding this. And we'd like to isolate that so we have a better understanding of where our sources are coming from.
Excellent, thank you. And Matt and Chris, just to throw that question out to you about the PFAS and the plastics and trash, how does the county hope to include new monitoring of those things in the future? Do you guys have like an answer that you would like to comment on for that?
I can go first. No, I think is the answer, at least not at this point. They're certainly on our radar. We do have some like trash reduction programs at certain locations, but we don't have any targeted monitoring around any of those emerging contaminants.
We do have trash monitoring as part of our permit. We also have piloted a trash trap in at least one location in our county. It takes a lot of maintenance. And then the other thing, as far as PFAS, that is an ongoing piece of research right now as they've put it in the Occoquan Reservoir. So we're very concerned with that and working with Virginia Tech's Occoquan Monitoring Lab to do PFAS and PFOS related monitoring. That's kind of a separate extra thing that we're doing on top of all this other stuff.
Excellent. Yes. Michelle says everybody needs a Mr. Trash Wheel in their county. Agreed. Okay. And we did just have Lily put, would love to see if Chris could put the chart of the fall versus spring reference of urban watersheds up again, if possible. And while Chris is doing that, I'll go ahead and move on to another question. Do any of you use volunteers or volunteer collected data for your monitoring programs? If not, is there any potential for that in the future? And I'll leave that up to anybody who would like to answer.
I don't think Anne Arundel County has any volunteer monitoring programs where we use the data. I think my boss Eric should be on this call. I think we fund some work with like the community college and some of the nonprofits, but as far as how we use that data, I'm not sure.
Okay, excellent. All right. So Maggie did have a question for Chris. Does Chris have any idea as to why the seasonal variations in macroinvertebrate scores?
Well, that's a great question. And that's the $85,000 question. And our state currently says at the family level, there is no difference between spring and fall. So this was new information. Virginia DEQ is now well aware of it. We've looked at a bunch of different things, flow variability and a host of other items, and we're now initiating some imidacloprid sampling that we've been doing the last year or two with USGS to look at, and that's a pesticide that works on dipterans. So for people who are interested, there are particulate taxa in here that I gave this presentation is about a 25-minute presentation in 2024 at Maryland Water Monitoring Conference. This is highlights. So I can go into excruciating detail. So we're still looking into it, and hopefully at some point there will be a paper out with USGS and us together looking at it in more detail.
Excellent. Look forward to that. And Chris, Lily asked, could you go forward 2 slides? Excellent. Hopefully that's what she was looking for. She said, that's great. Perfect. Thank you. And I actually have a question about eDNA for Matt. So Matt, you did talk about how, right now you guys are just looking at and comparing, eDNA to your actual physical monitoring. Do you expect, with what you have seen, do you expect to be using eDNA not just as a comparison, but actually as a monitoring protocol anytime soon?
Maybe. I think we're not shying away from using eDNA. I think we've invested a lot of time and money and staff expertise in developing this. We won't be substituting our required monitoring with eDNA. If anything, we're looking to supplement that. And part of this large watershed assessment that we're hoping to get at is, at what scale is the minimum eDNA sampling effort we can do in a watershed that gets us the same information as if we had done more. So we can kind of, is 150 samples in the watershed might be redundant. Is 60 enough? How far away do they have to be from each other to get that same answer or get similar information? Um, so hopefully that answers your question. We're going to keep doing it. Where we go next sort of remains to be seen after this very time-consuming eDNA effort that we're doing this summer. So more to come, I think, in the next year or two.
Yeah, no, that's perfect. Thank you. And I coming from a standpoint of like working with a lot of people just coming out of college, getting into, young professionals getting into their career, would you recommend that people be looking into training on eDNA? Do you think that's something that's going to be big in the future that's going to be helpful for them expanding their careers?
I mean, personally, I think yes. I don't know where the science is going. I'm not, we have a person on our team who's sort of our eDNA expert. Um, I would say a qualified yes. I don't think it's going anywhere. But there is a lot that needs to be figured out. So that's kind of what we're trying to do. It's like somewhere between exploratory and informational at the same time.
Yeah, I think that's one of the coolest things about your program that you guys are very much into, delving more into it and, expanding it yourselves. So I think that's really commendable that you guys do that. It's excellent. Michelle, did you see any other questions that came into the chat? I know we are just about at one. Just want to make sure we're not missing anything.
Nope, I don't believe we missed anything, but Chris has his hand
Chris has
up.
his hand up.
So as somebody who might be interested in purchasing an eDNA backpack or the 150 samples, what is the cost per sample that that it costs, and how much did the backpack cost, if you know those things?
Um, the backpack sampler, I think, was around $10,000. I cannot offhand answer the per sample, if you like sort of exclude time. So yeah, the filters are not that expensive themselves. Um, but there's a lot of time that goes into it when you think of like landowner permissions and sort of the bigger picture stuff. I don't know though if we have a per sample cost. Brian, if you're still on here and are listening, if you have an answer to that, please feel free to add it to the chat because I don't know how to let you talk. Um, so 10,000 for the sampler, question mark for the other, at least in my end.
Excellent. So with that, I just want to thank you guys for joining us. This has been fantastic. I think I got a lot out of it. I hope our audience got a lot out of it. I think they definitely did. I appreciate your time. And I hope you guys join us for our upcoming webinars as well. Thank you very much. And I just want to see if we got anything in. I think we're pretty good. Okay. All right. Well, thank you guys. I hope you have a great day. Look forward to seeing everybody for our next webinar.